The Navy releases its long-awaited 30-year shipbuilding plan.
And some members of Congress are not happy with it. The nation's fleet of warships would get smaller in the coming year under the Navy's proposed budget for fiscal year 25.
The evolving security landscape has left no doubt. America's long-standing air and maritime superiority now faces challenges from growing great power competition and rapidly advancing technology. Conventional fleets and doctrines no longer guarantee dominance. On July 4, 2025, a landmark law, the OBBBA, Operational Battlefield Beyond Borders Authorization, was signed, injecting billions of dollars into military robotics, AI, unmanned systems, and next-generation American air and naval platforms. The rationale is clear. The future balance of power will be determined by who can best exploit new technology across every domain. This is not simply an effort to add more ships or faster jets. It reflects a shift toward new forms of stealth, autonomy, and operational integration. The Pentagon's Replicator program, launched in 2023 with an initial investment of $1 billion, accelerated the development and deployment of drones. The Navy's fiscal year 2025 budget request includes $32.4 billion for new shipbuilding, with focused funding for modern destroyers and unmanned vessels. At the heart of air modernization is the Next Generation Air Dominance (NGAD) project, a classified future fighter drawing on lessons from the B-2 Spirit bomber and the advanced F-series before it. As these programs merge, one fundamental question emerges. Can such an ambitious, resource-intensive modernization reinvent stealth on a scale and with a capability beyond anything previously achieved? Or does the drive to build the ultimate fleet risk outpacing the systems and institutions that must field, maintain, and command it? How is America channeling over $100 billion to reshape stealth warfare? And what does this mean for the future of air and sea power? The blueprint for a new era. This drive toward an integrated stealth fleet is less a single program than the coordinated unfolding of a wider strategy across all military branches, with the Department of Defense acting as both architect and financier. Breaking from years of measured upgrades, policymakers launched into an accelerated phase of modernization. The OBBBA law stands at the center, unlocking comprehensive funding for robotics, advanced algorithms, unmanned platforms, and the integration of AI into both new and existing military systems. Take the Navy's 2025 budget request. Its $32.4 billion shipbuilding component is the largest single-year ship construction request since the end of the Cold War. This funding stream is designed to address a twofold problem: replacing older ships while redesigning the fleet to maximize stealth and autonomy. The strategy rapidly introduces 6 new ships intended to anchor a more survivable, more adaptive fleet. Modern destroyers, replacing legacy cruisers, incorporate lessons in reduced signatures and digital integration. This urgency stems from a sober assessment. Traditional fleets are becoming increasingly vulnerable to emerging threats: hypersonic missiles, persistent sensors, and a faster tactical decision cycle. The U.S. Navy's 2025 shipbuilding plan recognizes the declining utility of passive defenses alone. Survivability now demands a mixture of reduced detectability, adaptable materials, altered operational patterns, and robust networked information systems. The revolution in military capability does not stop at platforms themselves. There is now a focus on integration and mass. The Replicator program, with its $1 billion commitment, is steering away from producing a handful of expensive assets toward rapidly replicable, autonomous aircraft and ships. The intent: saturate the field, overload enemy sensors, and complicate targeting with sheer numbers and unpredictability. Supporting this movement is a cascade of funding in research and development. For fiscal year 2025, the Navy allocates $54 million for large unmanned surface vessel (LUSV) R&D and an additional $101.8 million for enabling technologies. This is not investment in hardware alone. It is directed toward seamlessly linking a family of manned and unmanned platforms, blurring the distinction between seen and unseen, crewed and autonomous. This organizational and financial drive, combined with a more focused 30-year shipbuilding roadmap, has clarified the strategic goal: assemble a distributed network of stealth aircraft, agile ships, robotic scouts, and AI-commanded sensors, each element interconnected, adaptive, and focused on survivability as much as offensive power. The question now is, how will these pillars, air, sea, and the information layer joining them, support the U.S. military's future deterrence and war-fighting capabilities? Skies of Shadow, advancing stealth in U.S. air power. Central to America's modernization plan is air power, where the Next Generation Air Dominance (NGAD) program leads efforts to sustain U.S. air superiority. Stealth is not a new concept for American air power. The B-2 Spirit bomber and ensuing generations of fighters revolutionized evasion tactics and detection avoidance. However, NGAD is expected to integrate stealth with speed and closely networked manned-unmanned teaming. Full details of the NGAD are classified, but its ambitions are made clear by budget documents and public statements. Building on the legacy of the B-2 and F-series platforms, NGAD is designed for extremely low radar cross-section, versatile sensor integration, networked operation with unmanned, loyal wingmen, and flexible digital upgrades. The hallmark stealth features of previous generations, shape, materials, and radar-absorbent coatings, are only the baseline for what is now envisioned. Industrial development is already underway, with contracts supporting rapid prototyping and targeted modifications. For example, a contract modification awarded to Lockheed Martin in August 2025, valued at $12.9 million, was part of this wave of incremental advances, representing the continuous refinement and adaptation of both hardware and software in current and future airframes. The broader air modernization strategy funds the integration of autonomous aircraft and swarms of drones into operational planning. The Replicator initiative, together with OBBBA funding, supports the growth of systems capable not only of flying alongside NGAD aircraft, but of conducting independent missions such as suppression of enemy air defenses and intelligence gathering. Operationally, this means stealth is viewed less as a platform property and more as an attribute of the entire air network. Enemy defenders must contend with decoys, unmanned aircraft, and piloted assets, any of which may be critical, forcing adversaries to guess which signals matter and which are distractions. This approach is intended to multiply options and resilience in contested airspace. Intelligence collection, strike missions, and support functions can be divided among piloted and autonomous systems, complicating enemy tactics and reducing vulnerabilities to a single point of failure. The persistent challenge, however, is in staying ahead of adversaries who are also accelerating their counter-stealth technologies, distributed sensors, and AI-driven fusion systems. The cycle of innovation versus counter-innovation is relentless, putting pressure on the U.S. to modernize not only platforms, but their entire operational concept. Sea Change, the Navy's stealth revolution. The shift to stealth and autonomy is equally critical for the U.S. Navy. Older surface combatants, mainstays of American power projection for decades, now face growing risks from advanced missiles, reconnaissance drones, and improved enemy sensors that reduce the effectiveness of traditional defenses. The Navy's 2025 shipbuilding plan and proposed fiscal year 2025 budget directly address these emerging threats. The $32.4 billion in shipbuilding funding for fiscal year 2025 allows the acquisition of 6 new ships. While this figure includes a variety of vessel types, key components reside in the modernization and eventual replacement of Cold War-era Ticonderoga-class cruisers with highly adaptable, stealth-focused destroyers. These new destroyers draw on lessons in signature management, including hull shaping and electromagnetic control, and embed flexibility for upgrades as technology evolves. At the heart of the Navy's future force design is the development and introduction of unmanned vessels. The Large Unmanned Surface Vessel, LUSV initiative, received $54 million for R&D, with an additional $101.8 million for supporting systems. The LUSV project aims to field vessels able to operate alongside manned ships, acting as scouts, decoys, and contributors to both offensive and defensive operations. Future concepts envision manned destroyers working with networks of unmanned platforms, surface and subsurface, designed to absorb first strikes or to gather intelligence. This diversification adds resilience, complicates enemy targeting, and enables new tactics for distributed operations. The Navy's operational doctrine increasingly embraces mosaic warfare, distributing capability across more, smaller, and harder-to-target platforms, each node collaborating through encrypted, AI-enabled communications. The goal is to disrupt adversary kill chains and ensure a resilient force structure. Long-term, these concepts are embedded in the Navy's latest 30-year shipbuilding plan, narrowing future options to emphasize integrated, upgradable, and networked fleets, rather than reliance on small numbers of high-value assets. It is a strategy designed both to keep pace with technological change and to retain the ability to adapt to unforeseen threats. This new approach emphasizes not brute force alone, but agility, operating in contested environments, reducing exposure, and delivering effects through concealment and surprise wherever possible. The Unseen Offensive, Autonomy, and the Replicator program. The thread running through the entire modernization effort is the rise of autonomy. Where unmanned systems once occupied niche roles, they are now central to future operations, particularly as embodied in the Replicator program. Launched in 2023, Replicator set an explicit goal: rapidly develop and deploy scalable autonomous systems able to saturate the battlespace. Unlike previous incremental upgrades, Replicator is intended to field large numbers of adaptable drones and robotic vehicles, attritable, cost-effective, and suitable for diverse roles from surveillance to direct action. Cross-service in design, Replicator supports the Navy in supplementing a leaner manned fleet and the Air Force in developing swarming air vehicles for suppression missions and sensor disruption. In both air and sea, the logic is to overwhelm adversaries with mass, resilience, and ambiguity. Key technological advances include improved autonomy via machine learning, in-mission task reassignment, and robust network links for real-time sensor sharing and situational awareness. The Replicator program's operational concept is for autonomous agents, whether in the air or at sea, to adapt, coordinate, and persist despite losses, expanding the range and resilience of U.S. forces. Replicator's adoption of spiral development cycles, deploying, testing, and rapidly refining new capabilities, marks a shift from long procurement cycles toward adaptable, risk-tolerant acquisition. In combination with OBBBA funding, this enables fielding of new platforms and rapid adjustment to changing threats. Consequently, doctrine is adapting. Where previous generations relied on maintaining small inventories of highly capable manned systems, the new model favors larger numbers, distributed risk, and combined human-machine teaming. These transformations are not without complications. Questions persist over command and control, operational integration, and the capacity of human commanders to maintain awareness as autonomous system numbers grow. Training, trust in machine reasoning, and reliable communications will determine operational effectiveness going forward. Funding, contracts, and the industrial challenge. Behind these strategic and operational shifts lies the challenge of maintaining an industrial and fiscal engine capable of delivering the envisioned fleet. The stakes are high. The OBBBA allocates tens of billions for technology, capacity, and support. Specific contracts, like the 2025 Lockheed Martin Award, reflect an ongoing realignment toward distributed, agile industrial logistics. Every new class of ship or airframe, as well as emerging unmanned platforms, requires not just an investment in research, but in advanced manufacturing, secure digital supply chains, and skilled labor. The Navy has explicitly stated, for instance, that acquiring just 2 ships beyond its baseline plan requires an augmentation of over $3.2 billion to the fiscal year 2025 procurement budget. This illustrates the cost and complexity of expanding the fleet at scale. Modern military production increasingly favors modularity and digital engineering. The requirements for adaptable assembly lines, rapid reconfiguration, and modular part supply chains are woven into current planning. Sustained innovation and flexible contracting are prioritized to avoid stagnation and maintain relevance against adaptive adversaries. The LUSV program's R&D budget, together with separate allocations for enabling technologies, underscores the need for progress in fields beyond hull construction, such as secure software, electronic warfare, and operational testing under realistic conditions. Risks are inherent in such rapid modernization. Expedience may yield immature technologies, while caution could result in ceding advantage. The U.S. defense industrial base must therefore balance innovation speed with thorough testing and robust quality assurance, ensuring new systems perform as required amid the uncertainties of evolving threat. Ultimately, this synchronization between doctrine, industry, and funding is essential. The future readiness and deterrent value of the U.S. stealth fleet will depend not just on platform advances, but on the ability to adapt supply and sustainment processes to match operational demands in real time. Networked warfare, integration as the decisive factor. With investments in air and sea modernization converging, the U.S. is moving toward a future in which the ultimate stealth is achieved through the integration of networked and mutually supporting capabilities. The OBBBA envisions a force that is more than the sum of its parts, bringing together NGAD fighters, next-generation destroyers, unmanned vessels, and artificial intelligence to form a coherent, adaptive operational network. This network-centric approach goes beyond the physical reduction of signatures. Informational stealth, exploiting data fusion and real-time communication to mislead, confuse, or outpace adversaries, becomes just as crucial as traditional radar or acoustic stealth. In practical terms, this integrated architecture means that air platforms, surface vessels, and unmanned systems continuously share data, providing persistent coverage, early warning, targeting cues, and cooperative strike options. Machine learning algorithms help to analyze the vast flow of information, aiding commanders in identifying threats and making rapid decisions, even where adversary behavior complicates targeting or exposes vulnerabilities. Nonetheless, these benefits hinge on the reliability and security of communication and sensor networks. With rapidly multiplying programs and systems, risks of technical incompatibility, cybersecurity breaches, or doctrinal mismatches increase. Rapid fielding initiatives like Replicator require a concomitant focus on robust, redundant, and protected communications architectures. Strategically, the networked fleet is designed to confound the decision cycles of potential adversaries. By denying certainty about the location, composition, and function of operational units, the U.S. military aims to slow, disrupt, or even paralyze enemy targeting. The cumulative effect is intended to reinforce deterrence, shifting potential conflicts in the direction of uncertainty for adversaries and initiative for the United States. If this integration succeeds, it will extend the reach and deterrent capabilities of U.S. forces across multiple domains. The decisive factor will not be the invisibility of a platform, but the speed at which forces can adapt, hide, and strike, rendering geographic limitations or single-point vulnerabilities less significant than ever before. Redefining power and deterrence. The modernization programs detailed in the OBBBA and supporting budgets ultimately converge on a larger strategic aim: upholding deterrence. Investments in stealth, autonomy, and information integration are not just for winning on the battlefield, but for convincing adversaries that any conflict would entail unacceptable risk and uncertain outcome. The Navy's refreshed investments serve a twin purpose: projecting credible force in contested theaters and assuring allies of America's continued military capability. NGAD and its systems of systems approach intend to maintain American air dominance and operational tempo over key regions. Autonomy and mass, as focused on in Replicator and shipbuilding initiatives, support the projection of force at larger scales, but with lower risk to individual assets and operators. There are limits to technological advantage. Adversaries are already developing counter-stealth systems, leveraging distributed sensors and exploring AI-enhanced fusion and targeting tools. Advances in quantum sensors, data analysis, and integrated networks continue to challenge classic notions of invisibility in operations. Fiscal constraints also remain. Fielding and sustaining these ambitious plans will absorb over $100 billion in direct investments, with long-term costs likely to rise as operational requirements, maintenance, and upgrade cycles evolve. Choices about force composition, readiness, and industrial investments will continually shape American strategy. Still, history shows that strategic advantage accretes to those who innovate, not just technologically, but also conceptually. America's ability to adapt new tactics, successfully integrate systems, and make timely procurement decisions will shape its competitive posture. The path forward. As global security competition intensifies, America's investment in a new generation of stealth, unmanned, and networked forces continues apace. Congress, the Pentagon, and industry all play roles in translating legislative authority and fiscal resources into advanced capabilities across fleets and squadrons. Success will be defined not only by signature reduction or the presence of autonomous vehicles, but by the flexibility and sustainability of the forces fielded. The ambition is to retain the ability to deter and, if necessary, to prevail by ensuring readiness, integration, and rapid adaptation. Qualities that have long defined American operational success. The legacy of platforms like the B-2 Spirit is thus not just in hardware, but in the ethos of continuous innovation and operational foresight. With careful management of resources, industrial capacity, and doctrine, the U.S. aims to field a force that remains unpredictable, resilient, and relevant in the face of a dynamic security environment. The coming years will test whether this $100 billion investment will deliver not just technological prowess, but a credible, balanced, and enduring deterrent. In this, the ultimate stealth fleet is best understood not as a technological endpoint, but as an ongoing commitment to strategic agility, an edge not always seen, but always shaping the calculus of global security.